All right, so 11.2, continuing with conic sections. This section is on ellipses, and so an ellipse is just basically an elongated circle. Is one way to think about it. The definition we see here is it's a set of all points, the sum of whose distances from two fixed points is a constant. So we have two focus points or foci. And if we have any point along the ellipse, the sum of the distance from that point to each of these two focal points would be the same anywhere along the ellipse. And so that's a geometric definition there. If we look at the equation, if we look at the equation of this, it follows general x squared over a squared plus y squared over b squared equals 1. And typically the way you write these is a is always the bigger number between a and b. And whatever denominator a is in, that tells you the direction that the ellipse is stretched in. So if the a is under, or the bigger number is under the x, then it's going to be elongated horizontally. If the a or the bigger number is under the y, then it's going to be elongated vertically. And so in this case, the horizontal length would be 2 times a. So a and negative a will be the x-intercept, b and negative b will be the y-intercepts. And then the focal points, in this case, plus or minus c on the x-axis, and c squared equals a squared minus b squared. And then, of course, if we're going the other direction where we're looking vertically, then everything is just kind of flipped, but c squared is still a squared minus b squared. So a is always going to be considered the bigger number. And so whatever variable x or y that a is under, that tells you which direction that we're stretching this thing. And of course, in this section, we're always centered at the origin. We'll look probably in a later section at some that are not, and they're shifted, but for now, we're just always centered at the origin. So let's look at this first example. We have 16x squared plus 9y squared equals 144. And so the first thing you need to do is you need to get this equal to 1. So we're going to divide by 144. Divide both sides by 144. And that gives us x squared over 9 plus y squared over 16 equals 1. Now, it's just coincidence that the 16 and the 9 kind of switch with the x and the y. It just so happens that 144 is 9 times 16, but it doesn't have to be that way. And so this tells us that b squared is 9, a squared is 16. And so we can find the focal points. C squared would be a squared minus b squared. So that would give us 16 minus 9, which is 7. And then so c is plus or minus the square root of 7. And since the bigger number here is under the y, a is under y in this case, that tells us that we're elongated vertically, and so the foci would be 0 comma plus or minus square root of 7. And so then we can sketch the graph. Of course, we have a squared is 16, so a would be 4, and then b squared is 9, so b is going to be 3. So we have 4 and negative 4 on the y-axis. We have 3 and negative 3 on the x-axis, and then the graph looks something like this. If you can draw it better than what I can. And then our focal points will be square root 7, negative square root 7. So that's the basic thing. Here's a formula you need to make sure you remember. And then always remember that a is the bigger number, b is the smaller number. All right. Next example, the vertices are plus or minus 4 zeros. That tells us that we are elongated horizontally in this case. And then the focal points are plus or minus 2 zeros. So we know that this would be a, this would be c. So a squared is going to be 16. C squared is going to be 4. So we need to find what b is in order to find the equation, or b squared really is all we need. So c squared is a squared minus b squared. So we have 4 equals 16 minus b squared. So b is going to, or b squared, I should say, is going to be 12. So our equation is going to be x squared. And in this case, the vertices are along the x-axis, so x squared is going to have the a, or the 16, a squared, I should say, plus y squared over b squared, which is 12, and that equals 1. And then we can draw the graph. This would be a 4. Sorry, that would be the square root 12. Square root 12. Square root 12, negative square root 12, and 4 and negative 4. So this would be elongated. Even if it doesn't look like it in the drawing, it's elongated horizontally like that. All right, and the last thing we need to talk about is eccentricity. So this is just talking about how stretched out is this, and or how close to being an exact circle is it. So the eccentricity E is going to be C over A, where C squared is A squared minus B squared, or C is square root of A squared minus B squared. And then, of course, E will always, because of the way this is E will always be between 0 and 1. You can kind of see, as E gets closer to 0, gets more circular. As E gets closer to 1, gets much more elongated. So that's kind of the idea. So if we have the equation with foci 0 plus or minus 8, so that tells us that C is 8. E is 4/5, so E equals 4/5, and we know that E is C over A. So we have 4/5 equals 8 over A, so that tells us that A is 10. And of course, A squared is 100. So then we can find B. So C squared is A squared minus B squared. So we have C squared is 64. A squared is 100 minus B squared. So that tells us that B squared is 36. So B is 6. Or I guess for the equation, we need B squared anyway. So that gives us the equation. Let's see, we're elongated vertically. So we have x squared will be over b squared, and then y squared will be over a squared, and then that equals 1. And then if we want to draw this, we'll have 10 and negative 10. We'll have 6 and negative 6. And then there is our ellipse. And we can see this one, 0.8, that's going to be a much more elongated ellipse. So just a couple things to remember. Here's the E formula you need, and then you need, of course, the C squared. And those are really the only two formulas for this one that you need. And then, of course, the bigger number is always A, and that tells you which way these are stretched out, I guess. So if you have any questions, let me know.